Hi everyone. Today I am glad to present our work, Trade-offs between Group Fairness Metrics in Societal Resource Allocation. I am Tasfia Mashiat. My co-authors are Xavier, Gitiaux, Huzefa, Rangwala, Patrick Fowler, and Sanmay. The main objective of our work was to have a closer look at the allocation of social services. Our primary research question is, are the allocation of social services fair across different demographic or intersectional groups, such as white male and black female? Now, the fairness notion for social service allocations largely depend on how we define it and how can we quantify the outcomes to evaluate that fairness notion. In current fairness research, there are two major research streams. One is fairness in machine learning, specifically group fairness, that quantifies the biases among different demographic groups, such as asking whether two groups are equally treated based on false positive rate in a classification algorithm. The next one is in fair division. Given individual preferences, are the resources divided equitably among the individuals of different demographic groups? Despite of this two broad domain of fairness research, we look at two important factors that arise in many real-world societal resource allocation problems. First, instead of simply focusing on a set of identical resources that need to be allocated among individuals, there is often a whole set of different interventions in social services, each with fixed capacity constraints. Second, individuals may respond heterogeneously to different interventions. For example, it might be desirable for refugees to live in a city where there is already a substantial population from their place of origin. In contrast, they might struggle to get accustomed to a city lacking their cultural representation. Here, any allocation algorithm for refugee assignment should consider such heterogeneous responses of refugees towards the decisions. We consider these heterogeneous responses towards different intervention where there can be personalized baselines and best case interventions for each individual. Can we measure fairness of an allocation policy with respect to improvement over the baseline or the regret compared to the best case? Let's take a look at this example. Suppose we have three different types of resources, 1, 2, and 3, and three different groups of individuals divided into group A, B, and C. There is one unit of resource 3 and two units of each of resource type 1 and 2. The utilities or the individual responses towards each intervention are stated in the table. We can observe that the members of both groups A and B prefers resource type 1, but their utilities are different. So it seems demographically fair to be allocating one of each group A and B a resource of type 1 and one of each type 2 to individuals of group A and B. Individuals of group C gets what's best for them, that is resource type 3. Now consider what would happen if we measured in terms of these two intuitively possible measures of fairness. If we measure with respect to total regret for group A is 0.3, B is 0.5. It looks like group A is doing better than group B, but if we measure with respect to improvement, the total improvement for group A is 0.9 and group B is 1.3. It seems group B is doing better than group A. So how can we reconcile this? Even though group C is getting the best intervention with zero regret, the improvement for C is less than both A and B. We can observe the difference in such comparison based on utilities. However, they can be problematic due to their sensitivity. For example, if there is one group with higher utility values and the other group with lower utility values, there will be substantial differences between two groups in terms of both regret and improvement. But in some cases, we may need this kind of metrics and they might be meaningful. For example, if we focus on homelessness, there is a common assessment measure which tracks if an individual returned to homelessness within 2 years of receiving the services. Also, there is this common prioritization scheme where systems are tends to prioritize the most vulnerable individuals, where the vulnerability may be measured as the probability of a bad event, for example, returning to the system in 2 years, given that they receive no intervention or the least beneficial intervention. These vulnerability scores can be used as utilities for our fairness measure. Though in this talk, I'm going to focus on results to be additive because that provides sort of all of the intuitions. But in the paper, we also provide parallel result for multiplicative metrics of fairness where we are using ratios rather than differences. Let's take a look at some series. Suppose there are two groups we care about where the sensitive attribute S is equal to 0 or 1 and allocation policy A satisfies improvement fairness if and only if the average improvement over the least valued utility for group 0 is equal to 1. Similarly, an allocation policy A satisfies regret fairness if and only if the average regret for the maximum achievable utility for group 0 is equal to group 1. Finally, we let delta U denote the maximum utility gain that can be achieved by a service. If we again take a look at our previous example, we can see that the utility for base service Umax for group A is 0.8 and for group B and C it is 1. On the other hand, the utility for baseline Umin for group A is 0.2, group B is 0.1 and group C is 0.5. Then the values for delta U will be 0.6 for group A, 0.9 for group B and 0.5 for group C, which is clearly different than each other. Based on these two definitions and for similar cases to our example, our theorem states that if an allocation policy A satisfies both improvement and regret fairness, then it must be the case that the average maximum utility gain for group 0 is equal to group 1. That is a really strict condition on the expected differences in utilities for the groups because the difference between utilities for the base service and the worst service has to be the same across the two demographic groups for a policy to satisfy both improvement and regret fairness. Otherwise, it cannot satisfy fairness along both of these dimensions simultaneously. But things are even worse than they seem. We also prove that not only it is that you can't achieve both of these measures, if there are allocation policies that on one measure seems to favor one group and the same allocation policy on a different measure can favor the other group. Formally, suppose the average maximum utility gain for group 1 is greater than the average maximum utility gain for group 0. And also there is a policy A that favors group 0 and another policy A prime that favors group 1. In terms of improvement fairness, then there exists a policy A star that favors group 1 with respect to improvement fairness, but group 0 with respect to regret fairness. The implication from this theorem, we get that if we evaluate the same policy in terms of improvement and regret fairness, we can observe that they tend to favor different demographic groups. Well, that's kind of worrying, but we are just doing theory over here, and this is actually an existence result. We were curious to know, would this be possibly a real problem or it is just a theoretical curiosity? Now that we have seen the theoretical analysis of the problem and our theorems, let's get to a real world problem. We considered this homelessness dataset of a major metropolitan city. There is data about 3,375 households who received homeless services between years 2007 to 2014. This dataset includes the information of sensitive features such as disability information, presence of children, marital status, race, age, gender, and as such. Also, there are 3 different available homeless services provided to them: transitional housing, rapid rehousing, and emergency shelter. These services have their own privileges and limited capacities. Finally, we use the estimated probability of successful exit from the homelessness as the utilities. Following Kubi et al. 2019, where they used PAR to estimate the probabilities for counterfactual services. Here we have the households, the services with fixed capacities, and the utilities for each of the household. Now we will look at the fairness definition that we introduced in previous slides and observe the measures for the original allocation of services. First, we define the groups based on sensitive features such as gender, race, presence of children, age, presence of disability, and so on. Then we estimate both the improvement and regret measure between these predefined groups. We can observe that there is substantial trade-offs between different groups in terms of both improvement and regret fairness. For example, if we look at the groups defined by presence of disability in the household, we can see that the household without disability are favored in terms of degree fairness, while household with disability are favored in terms of improvement fairness. Similarly, if we consider youth, that means where the age of the head of the household is less than 25 with and without children as our intersectional sensitive feature, we can observe that without children households are favored by improvement fairness, whereas households with children are favored by reader fairness. In this result, for the same original allocation, the fairness measures result in favoring opposing groups. Our theories can explain these trade-offs in fairness measures based on the differences in average maximum utility gain delta U of the predefined groups. Let's take a look at the distribution of delta U of the considered groups. We observe the difference in distributions between two predefined groups quite substantial and statistically significant that explains the trade-offs in fairness measures. For instance, in panel A, we can see that the distribution of delta U for household with a disability is skewed to the right, which implies by assigning the best service to a disabled client has a higher impact in terms of exit probability than assigning a client without a disability to their most beneficial service. Also, the difference in distribution means is statistically significant with a t statistic of 8.5 and p-value is close to 0. Similarly, in panel E, we can observe that the difference between average max utility gain for household for youth with and without children is statistically significant with a t statistics of 17.06 and a p-value close to 0. These results illustrate how families with children differ in their responses to housing assistance compared to homeless individuals. We can observe the similar pattern in panels B, C, and D. The responses to housing assistance for different groups are heterogeneous in nature. In conclusion, I would like to add that our work has showed theoretical and empirical evidence that in resource allocation, depending on which baseline we are using, while comparing the group outcome, there can be different results for different fairness notions. More specifically, in the case of homelessness, we can see that the returns to homelessness vary more across which services the individual is getting than the others. These results can have serious implications. For example, though it might seem that the household with disability are doing favorably better in terms of improvement fairness, fewer of them are getting the best intervention for them, as the regret fairness measure is favoring the group without disability. There is many more results in the paper, such as multiplicative measure of fairness, random and utilitarian allocations. I want to acknowledge NSF for these generous awards. Thank you.